Every generative model you have ever marveled at hides a secret room. Not raw pixels, not words, but a compressed space of pure numbers where the model actually does its thinking. In that space, a face is just a handful of coordinates, and nudging one direction adds a smile while nudging another changes the hair. Similar things sit close together, and meaning quietly turns into geometry. This hidden room is called the latent space, and once you understand it, generative AI stops feeling like magic. Let's step inside. First, let's see why models bother building this hidden space at all. Raw data is a nightmare to work with directly. An image is a huge grid of pixel values, and every meaningful property, pose, lighting, identity, is smeared across thousands of them at once. Nothing is disentangled, so there is no single knob you can turn to change one attribute without wrecking all the rest. It is enormous, tangled, and almost impossible to control. A latent space compresses all of that into a short vector of numbers. Each point captures the essential factors of variation while throwing away the surface detail, and the axes come to stand for meaningful, learned features. Suddenly, the geometry itself carries meaning, and that is exactly what makes everything downstream, generating and editing, actually possible. So how does a model actually use this space? Follow it one block at a time. Start at the entrance. A model takes a raw input and encodes it into a compact latent vector, just a short list of numbers. All the messy detail of the original is squeezed down into the handful of coordinates that really define what this thing fundamentally is. Now look at how these points are arranged. Similar inputs land right near each other. So a cluster of faces sits in one neighborhood and cats sit in another. Better still, consistent directions emerge. One direction ages a face, another rotates the head, another swaps day for night. This is where it gets magical. Because the space is smooth and organized, you can walk in a straight line between 2 points and the output morphs gradually from one into the other. Or you can add a learned attribute vector to change a single property, a smile, glasses, hair color, while leaving everything else untouched. Finally, we come back out. The decoder takes a latent vector, whether edited or freshly sampled, and expands it back into full data, a complete image, a sentence, a sound. Sample a brand new point and decode it, and the model generates something it has genuinely never seen before. Strip it down and 3 ideas capture the whole picture. It is a compressed space of meaningful vectors. Instead of raw pixels or words, every input becomes a point in a lower dimensional space whose axes stand for learned factors of variation, the true dials sitting behind the data. Its geometry encodes meaning. Similar things sit close together, and directions carry semantics, which is precisely what lets you interpolate smoothly between points and edit by adding an attribute vector, changing one property while all the rest stay fixed. It is the core of modern generative AI. VAEs and GANs generate by sampling and decoding a latent point. Latent diffusion runs its whole expensive denoising inside this compressed space for enormous efficiency gains, and word embeddings are simply latent spaces built for language. Alright, let's lock in what matters. A latent space is the compressed internal space where a model represents data as vectors, capturing the essential factors of variation while discarding surface detail. Its defining property is that geometry encodes meaning. Similar inputs map to nearby points, and meaningful directions emerge that correspond to interpretable, learned features. That structure enables 2 magical operations: smoothly interpolating between points and editing by adding a learned attribute vector to change one property at a time. It sits at the heart of VAEs, GANs, and latent diffusion, and its main challenge is keeping the space smooth and disentangled so that edits stay clean. If you want more of AI's hidden machinery made clear, come explore it with us at standarity.com. See you inside.